Welcome to dynamic versus static polymorphism. In this lecture, we are going to be doing some really interesting things. We're going to be looking at what static polymorphism is, how it's used and why it's useful, and you've probably seen it a few times already using C++. And we're going to look at what dynamic polymorphism is and how that ties in to the use of the virtual keyword that Ben showed you in the last lecture. And we're going to show you how it's used and why that's useful. Okay, so let's dive in. First off, what is this word that I'm using? This word polymorphism is a little bit weird. You've probably never heard of it before. Well, it basically just means calling a different function implementation depending on the type. Okay, so it seems fairly straightforward. And to give you an example, what we're going to do is hop over here into Chrome, and I'm going to open up a website called cpp.sh, CPP shell, which is just because I don't want to start up a whole Visual Studio project, just to show you a couple of things. So what we're going to do is write a function called getSize. And the idea is that we can pass in a thing, and it will tell us the size of that thing. So it's going to return an int. It's going to be called getSize. And I'm going to leave the implementation and details out at the moment because I want to show you how I'm going to use it. Okay, so the first thing is we've got this stud out. Let's just repurpose this for our uses. What we're going to do instead is do a get size, and I'm going to pass it in 5, for example. And what I would expect to come out of there is the number 5, because the size of 5, I think, in our implementation of get size should be 5. Okay, so that's one thing. And then the next line, which I'm going to replace the rest of these lines with, is going to give us I'm going to give it a string. So it's going to be hello, for example. Okay, so obviously this isn't going to work yet, but this is weird, right? Because I'm giving getSize. What type do I put here in the arguments? If I put int, then it's not going to work for the second line. If I put stud string, it's only going to work for the second line and not the first. So this is where polymorphism comes in. In fact, it's a type of polymorphism called ad hoc polymorphism or static polymorphism. And the idea here is that we call a different function when we use a different type that we pass in. So for example, I will write int, and I will say int x, and I will return, we use the right style guides for Unreal, I will return x, like so. Okay, and then I write another getSize where I take in a stud string. So stud : string, that's the C++ string type. We don't have access to F string here because it's just raw C++. We're not using any Unreal stuff. And rather than returning x, because that's not going to work because it expects an integer returned back, we are going to, in fact, this is a little bit small. I'm going to see if I can zoom in for you guys. That's a little bit better, isn't it? Okay, so we are going to return dot length. So don't worry about this. This is just how a standard string works from the standard library. If I run that, go ahead, do the compiling, and sure enough, we get 5 and 5 because hello is 5 long. Now, if I add an extra character, then we should be able to see we get 5 and 6 because that's now a longer string. So that is what polymorphism is all about. We've got one function, getSize, but we've got different implementations that are called depending on the type. Very, very simple, but that's polymorphism for you. So if you ever hear people talk about polymorphism and you want to run away screaming, now you know how simple it is. It's just calling a different function depending on the type of the arguments. Okay, so this doesn't just mean for arguments though. So for example, we might decide that we want to create an animal class. This is a very common example, so bear with me if you've heard this example before. We're going to create a class. It's going to be called animal, and it's going to have a public method which is called makeNoise. Okay, so it doesn't return anything. MakeNoise is the name of the function. It doesn't take anything, but it does something, print something to stud out. So I'm going to copy and paste my stud out longness, and I am going to put something to I'm an animal. That's what it's going to say. Very simple. because we don't know what kind of animal we are, so we're just making a default guess. Very good. Okay, so let's just check that that works. If I create me an animal, like so, and I say animal dot make noise. Nothing fancy going on here. Let's go and run that. And let's make sure I've got my semicolons in the right places and everything is all in order. I need a semicolon at the end of my class. There you go. It says I'm an animal. Nothing strange about that. Now I might make a subclass of animal and call that animal cat, and make yet another subclass and call it dog. In fact, at the moment they're not even subclasses. I'm just going to make them subclasses, like so. In fact, public subclasses. I don't want to make it a public subclass of dog. I want to make it a public subclass of animal. The other one needs to be dog. So the cat is going to say meow, because that's what they say in English. They say other things in other languages. And the dog is going to say woof. And what we're going to do is make a cat and a dog to test this out. So actually not going to bother renaming these even. Okay, I will bother renaming them because it's a little confusing. It's a cat called cat, not animal. And it's a dog called dog, not animal. We run it, we get I'm an animal, meow, and woof. Each of them making their own noise, which makes perfect sense. And the reason for this is because it's using polymorphism. We've got the same method called make noise, but because it's a cat or it's a dog that we're calling it on, it calls the method that is made there. So this is, again, another type of static polymorphism. Now, I keep calling it static polymorphism. You must be asking the question, what's dynamic polymorphism? Well, let's have a look. There is a definition for dynamic polymorphism. That definition, it only changes slightly. It's calling a different function depending on the type, when the type is only known at runtime. Okay, so we only know the type of this thing at runtime. What is a good example of that? Well, imagine that I had not just an animal, but an animal array, okay? And in this animal array, I'm going to put many animals. So on this farm, he had a cat and he had a dog, and he stuck them in the array. So old MacDonald, he is having an array of cats and dogs at the moment. He might have a cow later on. On his array, he had a cow, E-I-E-I-O. And in my array, I'm going to have a cat and a dog, like so. Okay. Now what I'm going to do is say animal, well, this needs to be animals now. Animals, and I'm going to get my 0th element of animals, and I'm going to do a make noise. Okay. And then I'm going to do animals 1 dot make noise. Let's run that and see what happens. In fact, what do you expect to happen? Maybe have a little pause, have a little think through. What would you think is going to happen in this case? And let's see whether that is actually what happens. Oh, we need a semicolon there, of course. Let's run it. Oops. So I'm forgetting my syntax slightly. These brackets to make it an array need to go after animals, like so. Let's run that. Okay, now this is odd. Why is this happening? We've got a cat and we've got a dog in this array, but when I call make noise, it's saying I'm an animal rather than meow or woof. What's going on there? Now this is what it means by static, not known at compile time, known only at runtime. Because this array we could change and mutate depending on user input, we don't actually know what type the objects inside this array are, which means that when it calls make noise, it can only call make noise of animal rather than the actual make noise implementation. That's a bit subtle, but basically it means that if we don't know what type of animal is going to be in this array at compile time, which we might not because it's an array, then make noise has to go for the general case rather than the specific case. That's for static polymorphism, but for dynamic polymorphism we can go a little bit better. And the virtual keyword is the key to this. So you've seen how that works in the last lecture, you've used it in the last lecture, and I'd like you to go ahead and use your knowledge of virtual and override to make these animals behave. What do I mean by that? That each call should call the right behavior. It should say meow and it should say woof. Pause the video and have a go. Okay, welcome back. So let's go back to old MacDonald's farm and get these noise-making animals working correctly. So the key to this is to use dynamic polymorphism, we need to use the virtual keyword. You may have guessed it from the last video. So here we are. Oh, I don't need to save because I'm on the web. Virtual make noise, and now we would have a make noise override like so, and the same for cat as well. Let's have a go at running that. Okay, so it's still saying I'm an animal, which is not quite what we would expect. Now, the reason for this is really quite subtle, and I wouldn't blame you if you didn't get this in the challenge, but it's good that you tried anyway. Don't worry if you didn't get this, because C++ is very subtle with these things, that when we are passing cat into this array, we're not actually passing this cat that we created, but we are making a copy. And because it's an array of animals, it turns it into an animal. So what's actually happened here is that when we copy it into the array, it's turned it into an animal. So what we need to do, and the only way really to make this dynamic polymorphism work, is to operate on either references or pointers. And because we need to put pointers in an array, we're going to make this an array of animal pointers. So let's just do that. If I do animal star, and then passing it in, I need to get the address of cat and the address of dog, and then I need to use the arrow operator with make noise, like so. And let's try and run that. Boom, magic. With a virtual keyword, we get dynamic polymorphism, which basically means that if it knows the type at runtime, if it knows the cat and dog at runtime, then it knows to call meow and it knows to call woof. And that is why we need a virtual keyword. And in the next lecture, we'll see why C++ doesn't make that the default, why we have static polymorphism as the default. By having a little bit of a look at the underlying implementation, I'll give you a little hint. It's called vtables if you want to get ahead of yourself. So I will see you in that lecture.